Analytics from IT and government sector. Welcome Mr. Vinayak Korse, Vice President, DSCI, who will be moderating the session. I also welcome Mr. Narendra Nath, Joint Secretary, National Security Council Secretary, and I welcome Suresh Chandra, Scientist Security Lead, STQC, and I welcome Mr. Muratai Anil Kumar Singh, Chief Information Security Officer, Ministry of Power, and I also welcome Mr. Andrew Jamison, Director, Technology and Security, United Laboratories. Once again, a very warm welcome to you all. Handing over the session to the moderator. So, over to you.
Yeah, thank you, Namushan. Thank you, Arnath sir and Mr. Andrew for joining us today. In these next 40-45 minutes, what we would like to discuss is this becomes an important concern area, especially in the context of now a lot of devices, including IoT, is now increasingly susceptible for the supply chain specific security risk, and we would like to deliberate on a larger ramification at national level and at a specific level. What are those kind of challenges and solutions which has come to solve this problem basically. So, probably in coming couple of years, this will become one of the important area in the discussion of larger security that we would be looking at. So, I think I'll start with Andrew, with you, because you have been in a business of testing products for this kind of a sensitive risk, which usually security professionals in the usual paradigm, they may not be really aware about the problems and issues and things that go in terms of testing. We have security tester, we have security assurance checker, but probably not to the extent that they can be used and leveraged for the testing of the products for the supply chain security risk. So can you just help us understand how does UL get into this one, what kind of work that you do, and how does this solve some of those larger issues which are now increasingly
chain security, and particularly when it comes to really understanding the threat models, what can go wrong, why these things go wrong. And we've seen, for example, just over the last week, examples of even very mature, security-sensitive, security-mature companies being exposed to supply chain risk and supply chain problems through software vulnerabilities in products as well. So I think that the biggest challenge we face today is that the complexity of products. We have products these days that really aren't made by a company, they're assembled by a company. They make their PCBs somewhere, they have their chips come from somewhere else, different components, sub-assemblies, they all have different aspects of software in there. And managing all of that supply chain, when your suppliers have supply chains and their suppliers have supply chains, is a very, very complex thing. We can't understate that. So it's a very challenging problem.
Yeah. So help us, means if you are engaged in this kind of testing, so how that is different from the typical security testing that you would basically engage into. So how this is different, and the lab that you have, and you also have the presence in India now, you also do such kind of work in India as well. How does that is different from a typical security testing and a security professional would be doing?
So it depends a little bit on the two sides of it. When it comes to pure component security testing, if we're looking at IoT systems, often it's quite new to these companies. It's not like when we're very used to working in the payment industry, in the government industries, working with hardware security modules and banking devices and so forth. And a lot of these companies understand the process that they have to go through, and so they've built security in from the design phase, and that's a great thing. We still find problems, but they're generally fewer. In the consumer market and the commercial market for IoT, even in some aspects of the government market, we find that there is a lack of understanding as to what they know, what they need to do. And so what that means when we come to test, we ask for evidence for information, and it might be lacking. So quite often the work we have to do involves directly reverse engineering the product and actually informing back to our customers, here are some things that we found, and it's actually news to them. It's something that they didn't realize themselves because they don't understand. Once again, they're assembling these products. They don't necessarily understand where it's coming from. When it comes to supply chain and looking at that, it's really about working through with these companies where they're getting everything, how it's coming in, making sure they've got controls in place, and helping them really internalize and understand what risks they're willing to take, because nothing is perfect, and what level do they want to mitigate to. So it's much more of a process on the supply chain side as opposed to more technical work on the product side.
Yeah. So here I would like to now seek views from Narendra sir in the overall discussion of our security, and especially from the national security perspective, and we are also now charting the national cybersecurity strategy. So how much weightage that we basically give to the issue of supply chain security, and why that is becoming important? One, definitely the critical sector and the conventional kind of infrastructure coming into the system, but now IoT and a lot of those new devices which are coming and joining the network. So how we are charting our strategy for this?
Yeah, actually, this counterfeit products or malicious products is a problem statement that's been there for quite some time now.
Yeah.
Of course, counterfeit products have been there, and we have got Bureau of Indian Standards, which is actually an organization that actually gives you tests and gives you a mark of assurance that the product is genuine. But that is what regarding the quality of service. So when you look at counterfeit products, there's one quality of service element that is there. But I think here we are looking at the security aspects of counterfeit products. Like, coming from a telecom background, let's say counterfeit mobile devices, there are issues with RF radiations. There could be health issues because of that. And there could be, issues regarding how it behaves in the wireless environment. So that is one part. But security is a consideration, and that is what we are looking at. From a national security perspective, yes, it's very important. And you would have seen that there are a lot of initiatives that the government has taken to ensure that we have a clean supply chain. So, we have the STQC, for example, has, established security test labs, especially for the software-related aspects at Kolkata, the CC, Common Criteria Labs, testing labs at Kolkata, Delhi, and Bangalore. And the labs at Bangalore and Delhi are, things that have come up in the last couple of years. And the Kolkata lab also was into certain other areas, and it's been upgraded to be able to do CC testing there. So, and further, the Department of Telecommunication also, there was a cabinet approval for telecommunication testing and security certification project that was there. And as a follow-up of that, we have the National, Communication Security Center, NCCS, center that was National Center for Communication Security, that was opened in Bangalore in November 2018. The idea there is that, the telecom licenses also provide that any equipment that goes into the network should be security certified before it goes into the network. So that facility there is coming up with requirements against which the testing and certification can happen. And based on that, it goes into that. Then regarding counterfeit devices, it's a big law enforcement problem that is there in terms of the duplicate IMEIs that goes into that. Though the standard, the 3GPP and the ITU say that, the IMEI should not be, it's not possible to change it, but still it's possible to change it. And we have lots of devices with duplicate IMEIs which are in the network, which is a law enforcement headache. For example, lawful access if you want to have to a device, and you are trying to track a device for a criminal element, and then you have multiple devices with the same IMEI, it becomes very difficult to do for the law enforcement to do their job. So there's an initiative called the Central Equipment Identity Registry that has been created. There's a proof of concept project that has taken place in the state of Maharashtra, where it's been implemented, so that there the identity is going beyond the IMEI to include the MC and the MS-ISBN and the MC, along with IMEI, to form a triplicate of an identity, so that we have unique identity in the system, and we can actually weed out fake, duplicate or counterfeit devices from the network. So that is one. And then we also have, regarding the IoT devices, the TRA has come with a recommendation for having a national trust center, so that we have a national registry for devices. And that is also, there's a group in Telecom Engineering Center along with the industry that is working on the contours of that national trust center and how it should be for that. So that is one part. Internationally also, if you see, there's the ITU Study Group 11, which is on signaling requirements, protocols, and test specifications, which is having a question 15, which talks of combating counterfeit and stolen ICT equipment. So there also we have, people are, seized of this aspect. And from India, we have CDOT, which has been actively contributing there and for, the stakes and counterfeit, how to address that issue. Then, when you look at all of this, the other aspects are also there, regarding, and you also have this rule that has come in the year 2017, where, anybody who has an equipment that can tamper with the IMEI and a mobile device, it's an offense under the Act, and then, you could be imprisoned for 3 years. Even if you have an equipment for doing that, or if you do that, you could be imprisoned. That rule was brought out in year 2017, a new rule. Then we have provisions in the Section 65 of the IT Act regarding modifications in software, which is prohibited under the 65. So we have a legal framework, and we also have initiatives on the ground that are actually trying to convert all of this into mechanisms for addressing this issue. But yes, having all of this, there are also aspects of enforcement, mechanism for enforcement, mechanism for surveillance activities to see, though we have standard setting, but how it happens, and also customer enablement. For customers to actually identify, when they go and purchase a device, how do they identify, how do they obtain a genuine device? So both the retail sector, also enablement of the retail sector to, sell proper devices, and for the customer also to be able to recognize a proper device and buy it. So these are all aspects that
I think these are good. I think if we would want to create a chain of the activities that are being practiced. One is creating these centers which can probably take a responsibility of testing, registering devices. That is one important part, and probably that work can be also provided by some of the experts like United Laboratories here. And there is another important thing is there some compliance requirement in telecom which has evolved in terms of compliance requirement, but there is recently I looked at even Ministry of Power has come up with a new requirement for the power sector companies that they should be getting the devices tested for supply chain security. So those kind of mandates also really put that pressure of investing and committing more to test or to take care of the supply chain security. Otherwise, the companies working, they may not be really worried about the issues that are at a product development level, basically. So sometimes these kind of and then there is a continuous watch and mechanism. For example, I always have one important challenge here is you can, as you talked about, is the buyer of a product or buyer of a technology, they should also get enabled. These mechanisms also enable the buyers quite significantly, especially common criteria, some of these kind of requirements coming from the compliance requirement. Basically, those who are in the organization, the compliance requirement do help them to commit more for the cyber supply chain security specific issue, and some of those kind of certification, registry, and the checking method is definitely important part. So most of these compliance requirements and especially the supply chain issues are largely tied to the development process, especially the common criteria is focusing on a development process, and that development process provides you the legal level and helps you to take those procurement decisions and specify procurement decisions. But apart from that, do you see any other areas which are emerging which can take care of supply chain issues in the operating cycle of a particular device? And I know telecom department has come up with some kind of a requirement where there's some liability which has been fixed to take care of the security issue. So the operating cycle issues of a supply chain is definitely one area which probably needs more kind of attention. So what do you see? What is your views on this, sir?
Okay. Yeah, actually, actually the operating cycle. One is you initially certify one device, but how do you know that the same device is actually coming to the market? That's where I was talking about the surveillance enforcement and really stiff penalties where there's violation. So that is very important. It should become very costly for a person to violate. So that is one part of it. But that is for the initial induction of equipment into that. But then the problem with ICT equipment is, over a cycle, it's not like a car that you purchase today, you got a good product and then, you run it for a long time. Right. And it's only when you have to replace a spare part that, you have to look at the spare part to see if it's a genuine spare part or not. With the ICT, especially the software updates that happen, updates and patches that come, and the frequency is so high, how do you manage that? Because you could get a very good product. One is the counterfeit part of it, but the other part is the patch management from a malicious actor, is one part of it, and the other is also the patch management by the person who is actually giving you the patch. We have had instances where, because of supply chain issues, people have got patches thinking that they are from genuine sources, and the systems have been compromised. So patch management has two dimensions. One is you get a patch from a genuine source, but the source is malicious, and you have patch management of patches to ensure the identity of the source from where you get the patch. So there are two dimensions. So patch management, staging, how do you stage the patch and test it before you actually incorporate it into a working system is a system that's been built into operation. Yeah, that is one. I think all the companies which are there, they have to have a staging system for managing patches. And that's one thing. What was the other one you mentioned?
Yeah.
Just get it with me.
Yeah, Mr. I was looking at the enablement, the certification mechanism like common character also focuses more on development process. Than actual security, actual outcome of a security. So sometimes they enable decision making, but sometimes too much focus on development is provided by the certification scheme, and here I think Andrew can also add value here. Yes.
Just because to answer that, actually one of the things is security has multiple dimensions. What the common criteria tries to do is to have to have a proper security by design and built into the network system. That is what they look at. I think having a proper process in place helps you to control. And then, see that whatever you have thought should be there, part of it gets actually into the system. And there's a repeatability of that. So that is what it helps in. So this is
definitely one important component is focusing on development process, and that definitely common character solves that. But when the product comes there, and I think if you can reflect on 2-3 things basically. One is definitely the operating cycle. How does the supply chain security issue that you address, and what are those methods which are coming in? And second part is there are some standards like 20243 which has come, right? And these standards are now increasingly being adopted, and more importantly, they are also increasingly being prescribed as well. For example, Ministry of Power in India has been now talking most of the OEMs to have the 20243 standard compliant for their production for devices they have been looking at. So can you just help us understand these two issues? One is the operating cycle, and other is the roll-up standard and which are those standards basically that are at play to probably address the supply chain security issue.
Sure. They're very good questions. When it comes to the assessment of products, as was mentioned, you can assess one product, but you don't necessarily know what's being shipped. Is it the same as that? There's that one golden sample that you assessed in the laboratory. But the discussion around patches is very salient as well. And I think it goes beyond the 2 points that were raised, in that it's not just, where's the patch coming from, and is it correct? We require these days in our products to receive patches. It's often built into the standards that there must be a vulnerability management program. You must have a process for fixing and remediating vulnerabilities in your systems. So that's great. But when we have assessment criteria where we've assessed a product with firmware version, software version X, it's shipped, and then they need to patch something, it's no longer firmware version X. It becomes something different. And increasingly, product firmware is not the entirety of the system. You have back-end systems that it relies on. You might have mobile phone applications. These are all being patched and updated at the same time as well. And often in the back end, they might have releases, every day, perhaps multiples per day. And so the traditional security assessment concept of, I'm going to assess this product and we're going to make sure this product is acceptable, really has facing challenges in today's world of updates, of interconnections, of software, and so forth. So it is a challenge, and what we've seen in some of the more forward-facing standards is you don't necessarily assess a product and then base it on instances of time. You do assess the development process, but although that's not only how it was developed, it's also how it's going to be maintained, and you can come back and validate that rather than validating each software update. You do it per year or something like that, and that's really important, I think. Another point I just wanted to get onto with the patch management, what we saw with the FireEye problems with the SolarWinds software issue, that was a valid software update. Their software build system was compromised, and a nation-state actor inserted malicious software into that. So even when you're installing proper software updates, you're still potentially open to vulnerabilities. And then we come to standards. How do we address this? I think we're still figuring that out, to be perfectly honest. I think the standards that we've got out there, you mentioned the IEC and the open standards, they're really good. But they're still, looking at the product life cycle, and our own vendor security systems look at that as well. But I think we need to also mature to, how do you start to build and develop secure software components and make sure those each individual secure software components, whether they're libraries or open source modules, whatever they are, they can be distributed with a known security software chain, with a chain of trust, if you like, that you might see in food production. We need to build that into software systems, and we're right at the start of that. There's a long way to go, is what I'm saying.
So we had been talking in terms of software, but now let me bring the discussion to hardware and chip and design manufacturing, because that supply chain we've been mapping. So the designing is most of India is the design capital of the world in terms of the semiconductor design, and there are so many companies and so many resources which are working in the design of the chip in the country. But manufacturing happens all across. The packaging happen in different country, and there is a supply chain of a larger product ecosystem. Supply chain of individual one chip is also very different, and that leads to a lot of those counterfeit ICs coming in, lot of ICs which are over manufactured and probably used for many other reasons. So how do you see to solve the problem associated with the hardware and chip basically? Are there some methods which can be suggested?
Seen with some of the security chip vendors that we work with, tried to address some of these issues and build in things like PUFs, physically unclonable functions, into the silicon, so you can essentially have a challenge response at the hardware level in the product to validate it. Also things like secure cryptographic keys and so forth, which are baked in at the factory to allow you to validate. And I think that sort of attestation, whether it occurs at the actual silicon level or a level higher, is probably something that we're going to see more of, because people tend to think each chip is, if you make it in a factory, it's identical to another chip that's made at the same factory. Every piece of hardware is unique because it has different manufacturing days, different silicon, slightly different doping that goes into it, these sorts of things, which is why you have yields and so forth in chips. So you can, to some extent, still qualify, still uniquely identify chips, and building functions in to make sure that that becomes part of the identification of the fingerprint of that component. At a, when you're talking about high-end ICs, high-end microcontrollers, microprocessors, that's probably where we're going to go. I think the challenge is when you're looking at the cheaper end of the market, smaller microcontrollers, other silicon that might be just performing non-smart kind of functions, that becomes much more challenging to validate, I think, and that's going to be a tough nut to crack.
Yeah, Mr. Chandra, you are here on the platform, right? He's from STQC, which is. So, can you hear us? Can you add from your side to the discussion?
Sure. First of all, this background is already set, so I will talk on Indian perspective, what we have done till now on supply chain side. So I will start with one of the notification of our Ministry of Electronics and IT, and this is the notification for National Electronic Policy 2019. So there it is clearly stated that to promote trusted electronics value chain initiative to improve national cyber security profile and control its supply chain across national defense. This include military, intelligence, space, etc., and critical national infrastructure like energy, grids, communication network, and the digital economy. So there is a seriousness from government side also. This is a very critical area, and with this I want to discuss here regarding what is supply chain perspective. So supply chain perspective is here, like we are having IT and communication product, and they are assembled or built, and they are transported also to multiple vendors around the world. And when we are talking about the software, and in software this include libraries, custom codes, commercial products, open source, like that. When we are talking about the supply chain, so security is an important aspect. And security, I mean to say here, when there are contribution from different sources, we are calling these sources as nodes. So they are storing some of the parts, some of the component. There is a line of transport also. There is requirement also, like it is a multi-source, it is multi-nodes, it is multi-routes, and there is a requirement of product integrity also in this scenario. And you raised the question regarding the standard. Let me briefly talk about the standard. Basically, there is a standard from Open Standard Group, and that standard is adopted by ISO IEC, and that standard is 20243. There is another standard from NIST 800-161, so that is also talking about this supply chain security. There is a MITRE technical report 140021, so that is also talk about supply chain security. There is another document from NIST TIR 8183. They are basically focusing on manufacturing side, like chip manufacturing. In Indian perspective, let me tell you in detail. STQC has launched the scheme for supply chain certification, and we have already started this pilot certification for one of the vendor in Noida for SIM. And briefly, let me tell you what is the scope of this 20243, because this scheme is based upon ISO IEC 20243. So this is divided in two parts. First part is technology development. Another part is supply chain security. And this technology development, basically, it is covering the life cycle of product development. So where it cover your software, firmware, design process, configuration management, for example, quality and test management, and in security side, the threat analysis, runtime protection, vulnerability assessment, product patching. And when we are talking about this supply chain security, so it covers risk management, physical security, access control, business partner security, counterfeit mitigation, like that. So briefly, let me tell you what is the process here. It is not the testing at product level. Basically, there is a requirement as per this standard. We are doing the audit of the process which is making the product. And the focus is on product. Like, for example, if I am auditing, let us say, completeness. Completeness here means all the requirement transformed to the design. So I will take one product from the manufacturing cycle, and I will verify, okay, these were the requirement, and all these requirements are transformed to the design or not transferred to the design. So design review, code review, all these things, they are there, and they are covered as per the process requirement. So there is no specific focus on any product. So this is a brief from my side.
Yeah, and one of the thing which is an important perspective to this discussion is to do this kind of analysis and do this kind of a verification and do this kind of assessment. You probably need a very different skill, right? And that skill probably needs to understand the design process, understand how the firmware has been configured or designed and deployed, basically. So you need a lot of hardware system level skills to really do this kind of assessment and this kind of work, right?
Agree with you. And in STQC, as we are already doing common criteria certification also, so we are having the experience of common criteria, and we are applying that experience in this supply chain also. So we are having experienced technical person in that area. So yes, you are right, it is required.
Yeah. So Narendra sir, one of the thing which I want to also discuss is there are two ways to look at supply chain. One is definitely we are getting these products and we are deploying those products, procuring and deploying those products. Those products are manufactured all across the globe and that are coming to us. But there's another interesting thing which I am seeing is we also have now a lot of semiconductor players. We also have now a lot of IoT players. We also have now a lot of players in a deep technology world, right? And then until now, in the context supply chain, only telecom or now critical sector has been discussed, right? But now, because of this, now every business manufacturing is now going to deploy so many of the products, basically. So the discussion is going to various different sectors. That is one important part. The second is, it's not only the procurement and adoption of the products, also people are developing products, and we should also have strategy for development as well, because the products which are getting developed here would be used in India and other parts of the globe as well. So that we should have two-pronged strategy. One is for procurement and other is for the development which is happening in the country.
Yeah. So I think basically what you're hinting at is there an initiative to see that we have development of indigenous products? Is that what you're hinting at?
So that is happening, but we need to bring the supply chain security specific agenda in that development process, basically.
Yeah. Okay. So, if you look at it, wherever this verification of supply chain or security of products is taking place, you will find that there is no mention that from where the product is being sourced. The security conditions, the testing requirements, the specifications, all of that are, agnostic to the source of the product. Currently, if you see, it's not mentioned. It's not. The same things are applicable to indigenous products. Are they applicable to products that are being brought into the country? So that differentiation is not there. Okay. So so it means that basically we want a secure product. And one thing about security is one is malicious intent is one, but poor design is also another part. Just because you have an indigenous product does not ensure security for you. So it's important. So it's important to have your security testing in place, and that is important. And the second part, of course, when you have a lot of development activity happening in the country now, how do you see to it that we don't retrofit security afterwards, but then get the security culture into the teams that are building it? I think that's what you're hinting at.
Yeah. So
yes.
So there are two things which is
so if you find that everywhere you talk, or any organization, even the TRI report that I talked about for IoT, and they have talked about secure by design. That we should have secure by design. So these are statements everybody makes, but on ground, how does it translate into actions is a point. So one is, yes, I think even in the educational system that we have, there is the security part is missing. People who are taught software development or system design, as make it part of the security. Security to be made part of that is an important component. I think that's where the first part where we have to address. And good, yes, that recognition has come, and you will find that many of the educational institutions, especially the undergraduate level and the graduate level, and that's becoming part of the curriculum now. Yeah. So, and I think you have a big role in that.
Yeah. So
making this. Yeah.
So another thing which I want to now cover is the Trojans which are implanted in hardware level, right? And that is coming as a big challenge. And briefly from all three of you, I'd like to hear is there are definitely some ways at a procurement level, verification level you can have, but largely the solution to that at a manufacturing level. But I'm not sure how do we solve that problem, because there are definitely some technology, some capabilities of emerging to help us solve that. But how do you, because this will become a very important problem, and some of those even larger service providers like Apple and Amazon has got a victim into some of these kind of things which happen with their sourcing basically. So what should we do in terms of solving that problem? Then sir, first you, then Andrew, and Mr. Chandra, if you have anything to say this.
Yeah. Yes, as you pointed out, there's been a lot of stress on, software, and there's an element of competence that has been developed in that area, and understanding, I'll say. And competence also is slowly coming out. Hardware security is something that is not really discussed in such detail. But, we at our office were seized of it. And we've been talking to people on that. And the sets, you must have heard of sets in Chennai. Yeah, so sets in Chennai, we have identified an area, is an agency which we want to develop into a center where hardware testing we develop competence in hardware testing. So we have asked them to submit a project proposal on that. And they've also had a consultant to, come up with a detailed project report for establishment of a hardware testing facility there. So when you talk of hardware testing, one is, of course, as you talked about, project level. Then and the other is at the PCB level, system and then after the embedded systems that are there. So all of these aspects have to be considered, and the skill sets, the equipment that is required, the processes that are required for all three of them are different. So if you want to look at a chip and for example scraping the chip and then looking at it, the tools that are required for that are different. And there is also a paper, as a consultant he has also written a paper on the economics of hardware, Trojans and all of that.
Yeah, I've seen that paper.
You have seen that paper. I've also seen that paper. He's discussed with us. So, we should not actually really go overboard on, going to research problems without really finding out how much does it cost for somebody to implant the Trojan and activate that. So these are areas that have to be studied. And then, so I'll not say that we do have currently any ready-made solutions for that. but that it's an area that we have to seriously work on that, and that we have started work on that journey. Yeah, I'm actually pleased. I mean, what STQC, Mr. he was talking about. I'm really pleased with the work that they're doing on that supply chain thing. I think offline I would like to get in touch with him about what they have started. Yeah.
So, Andrew, briefly, you can reflect on this hardware Trojan issue and how that will be changing the things that we do in supply chain security.
Yeah, I think I agree broadly with what's been said, particularly from the economic point of view. Hardware security, rose to the spotlight with a Bloomberg article that was about 4 years old now, I think, where there was suspected a hardware Trojan in some servers. That's been widely debunked and doesn't really hold water these days. I think when we look at software supply chain security, there's clear evidence, many tens of actual examples of security problems in that. We have far fewer in hardware, and it's mainly because it provides some sort of physical evidence, as was mentioned. If you do it at the chip level, that's really quite complex, much harder than polluting the software supply chain. If you're going to do it at the PCB level, you're going to have extra components and so forth, which are visible. The Bloomberg article that talked about embedding chips in PCBs. I've seen security products that embed chips in PCBs. It doesn't just happen. It needs to be built in. So I think I personally am far less concerned about that, because it would need to be very targeted. It would need to be very specific. I'm sure nation states are doing it, and if I was the military, I'd be concerned about it. But for commercial environments, I'd be less concerned. We have bigger fish to fry from a software side.
Are we doing something in the area? Are we planning to do something in the area?
You're talking to?
I'm talking about Mr. Chandra from STQC.
Okay.
Are we doing something in a hardware security specific work? I'm sure he's connected with us. Probably he's not. Okay. So I think I will now, just to conclude, I will get, sir, briefly your concluding kind of a remark on this panel from both you and Andrew, a very brief remark. How would we like to conclude the discussion today, that we had covered different issues and different areas, and there are definitely some tasks which has been charted out, some of the agencies which are working in, some standards which are in making as well. But we need a larger strategy which can plug all of these kind of components together and drive some of those real kind of action on the ground.
Yeah. See, one thing is, the industry should be interested in the activity that is happening. It's in their benefit that they do it. Like, for example, if you talk in terms of counterfeit, I'm talking of malicious activities, a different ballgame altogether. When I'm talking of counterfeit products, I think the industry should be interested in that genuine products get into the market. It's for their benefit. So they should work with governments to address that issue. That, how do we actually put in place processes and, share information about best practices, and how do we actually have a level of assurance that can be built. So it's important that the industry works with the government. It's not that, in isolation, both of them work in their own ways.
Yeah. So we are already now looking at, there's an industry association named AISS, which is the industry association of the electronics and semiconductor industry. So we are trying to now collaborate with them, trying to sign a partnership, only focus on supply chain security issue. And we already have a couple of interactions with them, because those are the industry we should be targeting in things that we have been doing in supply chain issue. So Andrew, any last comment that you would like to offer?
I think that the final thing that I'd say is that people need to understand that the electronic systems they use, the software that they're using, the hardware, the computers, the network routers, these sorts of things, they're all assembled from other bits and pieces, chips, other software libraries. They all have their own supply chains. We've worked very well at securing our supply chains for food. We've worked very well at implementing security over supply chains for systems for airplanes, for example. We really need to start looking at supply chain security for commercial and consumer devices, and we're really at the very start of it. I'm hopeful. I don't think it's an insurmountable problem, but it's not going to be something we solve overnight. It is going to be a decade or more long process of continually getting better at it. But it's exciting to be at the start, and there's a lot to do.
Yeah. Thank you, sir. Thank you, Andrew, for joining us today to discuss the very important subject of the one which will be occupying a lot of our time in the coming years actually together. Thank you, sir.
Yeah. Just hit the nail on the head. It's going to occupy a considerable amount of our time. Thank you.
Thank you.
Mr. Andrew. Good to see you. Bye.
Thank you.